Welcome to my channel. This is Franco Pantaleon. In this video, I will present to you the three very useful line equations and its applications. So we have three useful line equations. We have form 1, which is ax plus by plus c is equal to 0. So we have this form. This is our equation 1, the general form. The second equation that is very useful is the point slope form. So we have y minus y1 is equal to m times x minus x sub 1. We have this variable m being the slope of our line. Now another very useful equation is the slope-intercept form. The slope-intercept form is y equals to mx plus b. These are the three most useful line equations when dealing with problems for equations of lines. Now, m stands for the slope. Suppose we have point 1 and point 2. This is our point 1 and this is our point 2. And with coordinates x1, y1. And for point 2, we have x2, y2. Now the slope of this line, m, being equal to the difference in the distances y all over the difference of the distances x. We have here our delta y is equal to y2 minus y1, and our delta x is equal to x sub 2 minus x sub 1. So our slope is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So these are the basics when dealing with problems involving line equations. These are the very important equations that we need to use. Now another concept is about the concept of parallel lines. Two non-vertical lines are parallel if and only if they have the same slope. Supposing this is line number 1 and this is line number 2, and the slope of our line number 1 is simply equal to m, and then the slope of line number 2 must be likewise be equal to m. The equation being y equal to m x plus b sub 1 for line number 1, and for line number 2 we have mx plus b sub 2 for line number 2. So these lines are parallel. Now what about for perpendicular lines? Two lines with slopes m sub 1 and m sub 2 are perpendicular if and only if their slopes are negative reciprocals, and it can be expressed by this equation, such that line number 2 is perpendicular to line number 1 their slopes should be negative reciprocals. So M2 is simply equal to the negative reciprocal of our M1. Now, this information would be also helpful when dealing with vertical and horizontal lines. The equation of a vertical line is simply equal to x is equals to a, and the equation for a horizontal line is y is equal to b. So this is the graph of our horizontal and our vertical line. Okay, let's have our first illustrative example. Number 1. Find an equation of the line through point 5 and 2 that is parallel to the line 4x plus 6y plus 5 is equal to 0. Now notice that the given equation of the line is in the general form. And rewriting this equation, we have y is equal to negative 4x over 6 minus five over 6. So we now have the slope-intercept form. Now, based on this equation, we know that our m is equal to, if we reduce this further, we can reduce this further to 2/3 x minus 5 over 6. So the slope of our line is negative 2/3. Since we already have our slope, we can now use the point slope form to determine the equation of our line. The equation, our point slope form is y minus y1 is equal to m times x minus x sub 1. Our x sub 1 is 5 and our y sub 1 is 2. So substituting the values, we have y minus 2 is equal to, the slope is negative 2/3 times x minus 5. Now if we simplify this equation, this becomes 2x plus 3y minus 16 is equals to 0. And this equation is in standard form. This is now our answer. Okay, next. We have illustrative example number 2. Find an equation of the line that is perpendicular to the line 4x plus 6y plus 5 is equals to 0 and passes through the origin. So our general form is this equation. So we will rewrite this equation. We can rewrite this equation as y is equal to, again, negative 4 over 6x minus 5 over 6. And reducing further, we have y equal to negative 2/3 x minus 5 over 6. So based on this form, the slope-intercept form, we know that the slope of this line is equal to negative 2/3. Now, such that we have a perpendicular line, our needed slope should be the negative reciprocal of this slope. So we have our M2 must be equal to the negative reciprocal of our this line here. We might name this as our M1. And the negative reciprocal of M1 is equal to positive 3/2. Now we already know the slope of our perpendicular line. So what we're going to do now is we are going to use the point slope form. So again, we write the point slope form equation. We have y minus y sub 1 is equal to m times x minus x sub 1. Now our the slope of our slope here should be equal to 3/2. So we have, and by the way, it passes through the origin. Our origin is 0, 0. Therefore, our x1 is 0 and our y1 is 0. So we substitute the values. We have y minus 0 is equal to 3/2 times x minus 0. And our final equation is y is equal to 3/2 x. So this is now the equation of our line perpendicular to line 4x plus 6y plus 5 is equals to 0 and passes through the origin. So this is our answer. Now let's have one final illustrative example. Find the equation of the line passing through points -4, 7, and 3 and 2. Now we are given 2 points. With this information, we first determine the slope. Our slope is simply equal to y2 minus y1 over x sub 2 minus x sub 1. Now this could be our point 1 and this could be our point 2. So our m is equal to, our y2 is 2, our y1 is 7, over x2 is 3 minus our x1 is negative 4. So the slope of our line is simply equal to negative 5 over 7. Now, since we already have our slope, we can now again use the point slope form. So we have y minus y sub 1 is equals to m times x minus x sub 1. We have y minus, we can select any point. So in this case, we simply use this point here. So we have our y1 is 7, our m is negative 5 over 7, and our minus x1, our x1 is negative 4, minus negative 4. Okay. So we have y minus 7 is equal to negative 5x over 7 minus 20 over 7. Now simplifying this further, we have y is simply equal to negative 5x over 7 plus 29 over 7. So this could be the equation of our line passing through points negative 4, 7, and 3, 2. So this is now our answer. If you like the content of this video, click like and subscribe. Thank you. Welcome to my channel. This is Franco Pantaleon. In this video, we will take up exponential functions. We'll be taking up exponential function with base A and graphing exponential function with base A and natural exponential function and graphing of the natural exponential function and creating an exponential model for spread of virus. So this is the definition of our exponential function with base A. It follows this equation. So we have f of x is equal to a to the power of x. Take note that we have these different examples. So we have f of x equals to 2 to the power x. Our base here is 2. And we have g of x is equals to 3 to the power of x. Our base is 3. And we have h of x is equals to 10 to the power of x. Our base is 10. So that is how we define our exponential function with base A. Okay, so what we will do now is we will draw the graph of each function. So we have f of x is equals to 3 to the power of x, and another function g of x is equals to 1/3 to the power of x. And by the way guys, we already have the corresponding values for these different functions from -3 to +3. Now anyway, to make our life easier, I will show you how to create this table using your calculator. If your calculator have a table function, then you can easily create this table here. So our first step is we will be looking for our table function. So we'll press mode, and in this case our table function would be in for number 7. So we'll press 7. So we are now ready to input this value. So first we'll input this value, f of x equals to 3 to the power of x. So we press 3 to the power of, we press this, and x. So we press alpha x. That's it. We press equals. So we'll start with, in this case we'll start with -3. So we press -3 equals, and our end would be +3. So we'll press 3, and our step would be, the steps would be only 1. So 0 to 1 is 1. So our increment would be 1. So we press 1 equals, and there you go. We already have our corresponding values. So this is in decimal form. We'll press SD, and there we have it. For value of f sub x, f of x is equals to -3, or f of x is equal to 1/27. So that is how we get this value. So we will automatically, we have the corresponding values for our f of x. So when f of x is, when x is equals to -2, so we have 0.111. We press SD, then we have 1/9, which is exactly this value here. Okay, next, when f of -1 for value, when x equals to -1, we have f of x is 1/3. So that is how we get the value. Next, 1, and when x equals to 1, we have value of 3. When x equals to 2, the value is equal to 9, and when x is equals to 3, the value is 27 for f of x. So we have easily determined the value of our f of x for this particular function here, for when you have 3 to the power of x. So you can now easily plot your function. So for y equals to 3 to the power x, this is the corresponding graph. Now for g of x is equals to 1/3 to the power of x. So we'll press AC, and we might as well delete the value 3, and it would be a lot better if we will use the parentheses. And so we press left arrow, we press this key here, and we provide the values 1/3. Okay, so checking our equation. Okay, we'll press equals. We'll start again. We'll start with -3, and we'll end with 3. And again, our step increment would be 1. So there we have it, our corresponding values. So we have, for when x equals to -3, it would be 27. Okay, next is 9. Next is 3, 0, 1, and 5. 1 is 1/3. When x is equal to 2, our g of x is equal to 1/9. And last but not the least, when g of x equals to 3, our value is 1/27. So we have plotted now our corresponding function when g of x equals to 1/3 to the power of x. Okay, next. So this is our definition of natural exponential function. F of x is equals to e to the power of x. Now, in this case, our base is e, and which is referred to as the exponential function. So, what if we are required to sketch the graph of its function? So, we will graph this function and we will likewise graph this function. So, we'll do the same. Okay? We will solve that with our calculator. Okay, so take note, our f of x will press, our e is somewhere here, shift e to the power of x, alpha x equals. So again, we'll start with -3 and we'll end with +3. And our step is 1. Okay, so outright we have our values. So we have, when x equals to -3, our value is 0.049. When x is equal to -2, our value is, for f of x, equals to 0.1353. And when x is equals to -1, our value would be f of x 0.3678. Continuing 1. When x equals to 1, we have value 2.718. And when x equals to 2, for function, we have our e, f of x, which is equals to e to the power x, equals to 7.3890. And last but not the least, when x equals to 3, our f of x will be 20.0855. Okay, so we will now write down our corresponding value. So we have x -3, -2, -1, 0, 1, 2, 3. Now our f of x is equals to e to the power of x. Is equals to, which we have previously solved or determined through our calculator. Okay, so we'll write down our values. So we have, okay, 0.0, we'll run this off to 2 decimal places only for simplicity, and 0.14, and when x equals to -1.037, and 0, 1, we have 2.72, and we have 7.39, and 20.09. Okay, so we marked such that there will be no confusion. And when our f of x is equal to e to the power of -x, again we'll be using our calculator. So we'll simply add a negative sign, and okay, again we'll start with -3, we'll end with 3, and our increment, our step is 1. So we have these values. So we have 20.085 or 20.09, which is simply this value here. So when x equals to negative 3, for f of x equals to e to the power negative x, the value would be 20.09. Okay, checking the values. So the pattern is simply for when x equals to negative 2, the value is 7.39. So if we notice, this is just our value in reverse, starting with this value here. So having checked these values, we will simply write down the corresponding values in reverse order. So we have, so when x equals to negative 2, we have 7.39, and we have 2.72, 1, and 0.37, 0.14, and 0.05. And of course, if we plot these functions, then our e to the power x would be this graph here, and our e to the power of negative x is this graph. Okay, next, an exponential model for the spread of virus. An infectious disease begins to spread in a small city of population 10,000. After T days, the number of persons who have succumbed to the virus is modeled by the function. So we have b sub t is equals to 10,000 over these expressions here. So we are asked with this question, how many infected people are there initially at time t equals to 0? And find the number of infected people after 1 day, 2 days, and 5 days. Okay, so again, we will use this, the table function. So we'll use the parenthesis sign. We have 10,000. No, we will use parenthesis rather. 10,000 divided by this expression here. We have 5 plus 1, 2, 4, 5 e. We have shift e to the power of, so we'll use parenthesis such that negative 0.97 t. So in this case, we'll simply use x, negative 0.97 alpha x, close parenthesis, and again close parenthesis, equals. So we'll start with t equals to 0 and until the 5th day. The end would be 5th. Our increment would be 1. Okay, so we have these corresponding values. So how many infected people are there initially at time t equals to 0? So our answer here would be, based on the result, we have 8. Okay, this is our answer for letter A. Next, find the number of infected people 1 day, 2 days, and 5 days. So we'll inspect 1 day would be 20.97, 2 days would be 54.37, and the 50 would be 678. So in this case, since we are required to determine the number of infected people, then we'll round off our result to the whole number. So in this case, for after 1 day, there will be around 0, 1, 2, and 5th day, when time 0, 1, 2, 5, and the number of infected people. So the number of infected people would be, if you plot this out, 8. And for x is equal to, after 1 day, is equals to 21. We would expect there will be 21 infected people with the virus. And time t equals to 2, we have 54. And on the 5th day, we have 678. Okay, so that's it. If you like the content of this video, click like and subscribe, and thank you for listening. Bye bye. Welcome to my channel. This is Franco Pantaleon. In this video, we will discuss about logarithms. So we will cover the following. We will differentiate the logarithmic form versus the exponential form. Then we will highlight some graphs showing the differences between the logarithmic form and the exponential form. And we will highlight a summary explaining the common logarithm, natural logarithm, and logarithmic function with base a. We will also highlight 4 most useful properties of logarithms, and we will have some problem-solving applications. So this is our definition for a logarithmic function with base a. So notice that this is our equation. This is our equation for logarithmic function with base a. And we have this equivalent exponential form. So we have, for the, in log form, we have a to the power of y is equal to x. We have a in exponential form, a to the power of y is x. So in logarithmic form, this is our base and this is our exponent, which results to this number. In exponential form, this is our base, this is our exponent, which results to this number. So I hope you now have a clear idea of the logarithmic form and the exponential form. So we'll take up these examples here. So in log form, our base is this number raised to this number results to this number. In exponential form, our base is this number raised to this number results to this number. Okay, so we have here different graphs. This is our graph for a logarithmic function with base a. Take note of the graph. And if you are very observant, you should notice that the slope is decreasing. for our log function. If we compare that with the exponential form, the graph of this exponential form is this. Notice that the slope is increasing. We have another graph. This is our graph for this function. This is a natural logarithmic function here. And again, this is our graph. Compared with this exponential form, this function, this is our graph. The slope is increasing. So we have here another graph for logarithmic function with base 2. And we have here another graph which we will be able to compare the different graphs of this logarithmic function with different bases. We have base 2, base 3, and base 10. Notice the positions of the graphs for the different base numbers. So base 2 is above base 3, and base 3 is above base 10. Now we have here another graph. This is a graph for a logarithmic function with base 5, and if we have another graph with plus 2, then this must be plotted above our previous function. Okay, so we now have our table explaining the different properties for the common logarithm, the natural logarithm, and logarithmic function with base A. So our base for our common logarithm is 10. And our base for our natural logarithm is E, which is simply equal to, or E is equal to 2.71828, so on and so forth. And for our logarithmic function with base A, our base is of course A. In equation form for our common logarithm, this is our equation. In exponential form, this is our equation. Notice that this our base 10 to the power of y is equal to x. In exponential form, this base to the power y is equals to x. For the natural form, natural logarithm form, we have log e to the power of y is this number. In exponent form, e to the power of y is this number. For logarithmic function with base a y equal to x. Exponential form, a y equal to x. So, in this video, we will only cover the four most useful properties of logarithm. This is equation 1. Take note of this form. Equation 2. Take note of this form. And equation 3, which is very, very important if we wanted to solve for the exponents. And equation 4. So these are the four most useful properties of logarithms. You should be able to memorize these different properties of logarithms. So, as an illustrative example, suppose we know our variables b and x and our known is y, and if we are required to solve for y, then we can take the log on each side and we bring down the exponent y, and using the properties of logarithms, we will be able to solve for our exponent y. So let us have some practice first. Okay, so we have this expression. So take note that our base is 10. So we can use this common logarithm. For our calculator, we can simply use for common logarithm our log. Log 5 divided by log 8. So our answer is 0.77398. Okay, so we have our answer. So another illustration is this. So anyway, we'll move right away with the application. So the guidelines for solving exponential equations. 1. Isolate the exponential expression on one side of the equation. 2. Take the logarithm on each side, then use the properties of logarithms to bring down the exponent. And 3 is you solve for the variable. Now suppose we are required to find the solution of the equation 3 to the power of x plus 2 equals to 7, and up to, we are required to have our answer in up to 6 decimal places. So find the solution of the equation. So our given equation is 3 to the power of x plus 2 is equal to 7. So we take the log on its side. We have the log of 3 to the power of x plus 2 is equals to log 7. So we can now bring down the exponent. So we have, using the properties that was previously shown, we have x plus 2 log 3 is equals to log 7. So we divide by log 3. So we have x plus 2 is equals to log 7 divided by log 3. We can now subtract 2. We have x is equals to log of 7 over log of 3 minus 2. So our x is, okay, we'll use our calculator. We have log of 7 divided by log of 3 equals minus 2 equals, we have, our answer is negative 0.228756. So answer is negative 0.228756, and this is our answer. Okay. If you like the content of this video, click like, subscribe, and please share. Thank you. Welcome to my channel. This is Franco Pantaleon. In this video, we will tackle arithmetic sequence, arithmetic means, and nth terms. So we have this sample arithmetic sequence, otherwise known as arithmetic progression. So we have here the arithmetic sequence 2, 5, 8, 11, 14. Notice that we have a common difference between 2 and 5, which is 3. 5 minus 2 is equals to 3. 8 minus 5 is equals to 3. 11 minus 8 is equals to 3. And 14 minus 11 is equals to 3. The common difference is equals to 3. A1 being equal to 2, or A2 is equals to, we have 2 plus the difference 3 equals to 5. So it's similar here. We have this expression. This is our A2. And our A3 is equal to, we have A1 plus 3 plus 3. So we have 2D, A1 plus 2D. So our A3 is equals to A1 plus 2D. So we now have this corresponding pattern. As you can see, our A4, if we are going to continue, we have A1 is, or A4 is equal to A1 plus 3D. So we have a common pattern here. So these are the corresponding formulas often useful when it comes to problems involving arithmetic sequences. So we have this formula to find the nth term. We have our nth term is equals to E sub n equal to A1 plus n minus 1 times d. And for arithmetic means, suppose we have two numbers a and b there, then their arithmetic mean would be equal to a plus b over 2, since we only have two numbers. Then another probably useful formula would be also this nth partial sum of arithmetic sequence, which is equal to S sub n is equals to n over 2 times a1 plus a sub n. So let's have some illustrative examples. So what is the 10th term of the following arithmetic sequence: negative 5, negative 1, 3, 7, and 11? Notice here that these have a common difference of 11 minus 7 is equals to 4. 7 minus 3 is equals to 4. And this also have a common difference of 4. And this also have a common difference of 4. So we can see that our D is equals to 4. And our first term is equal to negative 5. To determine the nth term, we can simply use the formula. an is equals to a1 plus n minus 1 times d. So we can have our 10th term is equals to a1 plus our n is equal to 10 minus 1 times d. Since we already have values for our a1, we have our a10. Our nth term is equals to negative 5 plus, we have 10 minus 1 times d, which is equal to, the common difference is 4. Okay, then simplifying this further, we have our a sub 10. The 10th term is equals to 31. This is our answer. Another illustrative example, we have insert 2 arithmetic means between square root of 2 and 4 square root of 2. Determine the first arithmetic mean. Okay, let us write our numbers. So we have square root of 2 and we have 4 square root of 2. And we are required to insert 2 arithmetic means. We may insert these 2 arithmetic means C1 and C2. And to determine our number of terms, this is our first term, second term, third term, and our fourth term. Okay, we can use our equation. We have a sub n is equal to a sub 1 plus n minus 1 times d. So this is our a1, and this is our a, the fourth term. So we can write this equation as En is 4 square root of 2. We have A4. A4 is equals to A1 plus 4 minus 1 times D. So our fourth term is equals to 4 square root of 2 is equals to our A1 is equals to square root of 2 plus we have 4 minus 1 times D. Our only unknown is D. So this simplifies to 4 square root of 2 minus square root of 2 which is equals to 3 square root of 2. 4 minus 1 equals to 3. So we have 3D. Our D is equals to square root of 2. And our first arithmetic mean would be equal to, simply equal to the first term which is A1 plus the common difference which is square root of 2. Therefore, our C1 is equal to our A1 plus our common difference. Our C1 is simply equal to square root of 2 plus square root of 2. Therefore, our C1 is simply equal to 2 square root of 2. So this is our first arithmetic mean that we can insert between 2 square root of 2 and 4 square root of 2. So this is our answer. Another illustrative example, we have a sub. The first A1 is equals to negative 4 and the 25th term is equals to negative 100. We are required to find the 100th term. So given this information, we can target to solve for D. So we have An is equal to A1 plus N minus 1 times D. En for the 25th term, A25 is equals to, our A1 is negative 4, 25 minus 1 times D. And since we already have the value for the 25th term, we have this equation. Negative 100 is equals to negative, this is plus by the way, negative 4 plus 24 D. Our only unknown is D. So if we simplify this further, our D would be equal to, our D is equals to negative 4. Having known for negative D, our D is equals to negative 4, we can now find our 100th term. So our 100th term is equals to A1 plus 100 minus 1 times D. Of course, we already know our A1 and our D. Therefore, we can readily determine our 100th term. So we have the 100th term is equal to, A1 is equals to negative 4 plus 100 minus 1 times the D is equal to negative 4. And our 100th term is equals to negative 400. And this is our answer. So let's have another illustrative example. If the third term is equal to 8 and the 16th term is equal to 47 and a sub k is the kth term of the sequences and a sub k is equal to 212, then what is the value of k? So This is quite tricky problem. Anyway, so if we will simply write RA1, RA2, and A3. A3 we have known our A3, which is equal to 8. Likewise, we also have known our 16th term. Our 16th term is equals to 47. And our AK is equals to 212. Now, if this is an arithmetic sequence, then our A2 must be equal to A3 minus the common difference, since this is our reference number. Then our A1 is simply equal to A3 minus 2D. Okay. So this is a very, very important expression. Our A1 is equals to A3 minus 2D. Now, take note that we are given our 16th term, which is equals to 47. We will use this information here. So we have our AN is equals to A1 plus N minus 1 times D. Our the 16th term is equal to, our A1 is equal to this. Our A1 is equal to A3 minus 2D plus 16 minus 1 times D. And by the way, guys, since we already have known our A16 and E3, we have values for A16 and A3, then the only unknown is D. We can now solve for the common difference. So this is 47 is equals to 8 minus 2D plus, we have 15D. Solving for D, we have solving for D, we have this 15D minus D, we have 13D. 13D is equal to 47 minus 8 equals to 39. Our D is equal to 3. Okay, since we already have known our D, we can now determine our K given this information here. So, our AK is equal to A1 plus K minus 1 times D, which is similar to this equation here. So our AK is 2, 1i. Let me erase this first. Okay, AK is 212 is equals to our A1. Our A1 is equals to A1. So our A1, by the way, our D. So let us first solve for our A1. Our A1 is equal to A3. Our A3 is equals to 8 minus 2 times 3. Our A1 is equals to 2. Okay, so let us substitute this value here. 2 plus K minus 1 times the common difference is 3. Our only unknown is K. Therefore, we can solve for our K. Simplifying this expression and solving for k, we have k is equals to 17. K is equals to 17. So this is our answer. Next example. Insert two arithmetic means between 3 and 30. So let us write our arithmetic sequence. So we have 3 and 30, and we are required to insert two arithmetic means, C1, C2. Okay, so our number of terms are 1, 2, 3, 4. Now we know our fourth term, so again we'll use this formula. En is equals to A1 plus n minus 1 times d. En or A30. A4 is equals to A1 plus 4 minus 1 times d. So substituting the known values, we have 30 is equal to 3 plus 4 minus 1 is equals to 3d. Solving for d, 30 minus 3 is 27. 27 divided by 3 equal to 9. Our d is equal to, our d should be equal to 9. So we now have known our d. Therefore, our difference is equal to, common difference equal to 9. 9. Okay. And 9. So, our C1 is equals to 3 plus 9. This is equal to 12. Our C2 is equals to, we have 12 plus 9 is equal to 21. Okay. So, to complete our arithmetic progression or sequence, we have 3, 12, 21, and 30. And notice that the common difference is 9. 3 plus 9 equals 12. 12 plus 9, 21. 21 plus 9 equals to 30. So, this is our answer. 12 and 21. Next illustrative example. After 1 second, a rocket is 30 feet above the ground. After another second, it is 85 feet above the ground. Then after another second, it is already 140 feet above the ground. If it continues to rise at this rate, how many feet above the ground will the rocket be after 16 seconds? So, we're given the time in seconds. After 1 second, and the distance, after 1 second, the distance is 30. Okay, after another second, the distance is 85. After another second, the distance is 140. So you notice we have 85 minus 30 is equals to 55. 140 minus 85 is equals to 55. So we have a common difference is equals to 55. Since we are required to determine our 16th term, this is simply equal to A1 plus 16 minus 1 times D. So, since we already have this D, we have our A1, which is 30, we can readily determine our day. Our A16 is equal to, A1 is 30, plus 15 times 55. Our 16th term is equal to 855 feet. And this is our answer. 855 feet. Okay. The last but not the least illustrative example. An object is dropped from a plane and falls 32 feet during the first second. Again, we have this time in seconds. And we have this distance. So, first second, we have 32 feet. For each succeeding second, it falls 40 feet more than the distance covered in the preceding second. How far has it fallen after 11 seconds? So, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Anyway, we have plus 40. We have a common difference is 40. So 32 plus 40 is equals to 72. 72 plus 40 is equals to 112. 112 plus 40 is equals to 152. 152 plus 40 is equals to 192. 192 plus 40 is equals to 232. Anyway, we have this. We can solve the problem using this method. However, we will use the formula for us to solve faster. Our 11th term is simply equal to our A1 plus n minus 1 times dn. By the way, the common difference is 40. Our 11th term is A11 is equals to our A1 is 32. Which we have 11 minus 1 with the common difference of 40. Our A11, the 11th term is equals to 432. I will just complete this tabulation here so that everything will be clear. So we have 232. By the way, this is 11 is 432. 232 plus 40, we have 272. 272 plus 40, 312. 312 plus 40, 352. 352 plus 40 is 392. So guys, this is our answer. And as you can see, it is very clear that after 11 seconds, it has fallen 432 feet. I hope this clarifies everything. Okay, so that's it. If you like the content of this video, click like and subscribe, and please share. Thank you.